Okay, today's video is over the derivative of x to the power of x to the power of x. This isn't a lesson. I very rarely make videos that aren't lessons, but today I'm just going to do the derivative of x to the power of x to the power of x. And as the subtitle suggests, this is like completely useless. It really isn't applicable anywhere to my knowledge, but I just thought of this equation and I thought it would be enjoyable to derive. So that's what we'll do today. Okay, as I just said, there's no background info that we're just going to find the derivative of x to the power of x to the power of x. That's what we're told to do. We're going to begin by assigning x to the power of x to the power of x to y, meaning that the derivative of x to the power of x to the power of x is going to be y prime. So all we have to do is find y prime. So that should be simple. And to do so, we have to take the derivative of this here. Now that normally there exists no shortcut to do so. You can't really employ the power rule or the exponential rule. So we're going to have to try to simplify our exponents to make this a bit more manageable. We can do so by taking the natural log of both sides. Now, as you know, that brings down the exponent of the argument as a coefficient. So we end up with x to the power of x times cosine x. And from here, we can just take the derivative, and that should be quite simple. Let's begin with the left side. The derivative of natural log of y is going to be y prime over y, and this is because we equated the derivative of y to y prime. So that's just the derivative of y. And here, on the right-hand side of the equation, we're going to have to employ the, I believe, product rule. And so what we're going to do is we're going to find the derivative of the first term times the derivative of the second, plus the derivative of the second, plus the derivative of the first. So I suppose we'll start writing out what we have so far. X to the power of x times the derivative of natural log x, which is just going to be x. And we'll simplify this in a bit, so don't worry. Plus the second term, which is going to be natural log x, times the derivative of the first. However, that means that we're going to have to find the derivative of x to the power of x. And as I've stated earlier, or I suppose I stated that x to the power of x to the power of x has no shortcut for deriving. The same applies here. We can't really derive x to the power of x using the power rule or the exponential rule. So what we'll have to do, let me rewrite this in a separate color to show that this is like a tangent. I'm going off on a tangent here. So we need to find x to the power of x. I'm going to write that right here, actually. This is the derivative of x to the power of x to remind me as to what I'm doing so I can get back here later. And over here, I'm going to write what the derivative of x to the power of x is. You may have come across it before. A lot of calculus teachers like to assign it as some sort of bonus problem because it's not that intuitive, because typical derivative conventions don't really apply. So what we're going to have to do here is going to get rid of the exponent, and we can do so by, again, equating this to, let's say f of x, because we've already used y. Sorry, that should be f prime of x. F of x is going to be equal to x to the power of x. Now what we can do at this point is take the natural log of both sides, such that we end up with f prime, or sorry, natural log f of x is equal to x natural log x. And as I've said earlier, we're just moving the exponent down to a coefficient because that's what logs do. Now at this point, we are going to derive our equation. So we end up with f prime of x over f of x is equal to the derivative of this term over here, which is going to be 1 plus natural log x. And we can multiply both sides by f of x. And so we'll end up with something like this. F prime of x is equal to f of x times 1 plus natural log x. However, if you'll recall from up here, f of x is equal to x to the power of x. And so we can substitute x to the power of x in for f of x. And we end up with f prime of x being equal to x to the power of x times 1 plus natural log x. And so I'm just going to summarize a bit. The derivative of x to the power of x is x to the power of x times 1 plus x to the power of x times natural log x. Now I'm going to erase this work because it's taken up quite a bit of space, but just try to recall when we reference it later. And so what we're going to do is we're going to substitute that into our equation for the derivative of x to the power of x, such that we end up with the derivative of y over y is equal to x to the power of x over x plus natural log x times, times x to the power of x plus natural log x times x to the power of x. All right, that's a bit sloppy, but as I said, we'll simplify it later. So it's not really a concern. And over here on the, for the second term, we have x to the power of x over x. And that is equal to y prime over y. And I'll continue this equation over here. In fact, I'll choose a new color because I'm getting bored of purple. But what we're going to do at this point is we're going to multiply both sides with y such that we have isolated y prime, because that's what we're really looking for. And so we end up with y times x to the power of x over x plus natural log x times x to the power of x plus natural log x times x squared. Now, at this point, technically, this isn't technically correct by AP standards, but this is the derivative of y. And so I suppose you could say that this is correct. However, we're going to simplify it further. We're going to say that y prime is equal to x to the power of x to the power of x, and of course some other terms as well. But I just want to point out why we're substituting this, because as I've shown earlier, we equated x to the power of x to the power of x to y, meaning that later when we use y in our equation, we can substitute that in, or we can substitute x to the power of x to the power of x in for y. So that's how we got x to the power of x to the power of x. Now we need to simplify this this inside term, I suppose, argument, whatever you want to call it. Let's begin by focusing on x to the power of x to the power of x. Sorry, x to the power of x all over x. We're going to try to simplify this a bit. So let me just give you just a quotient. 3 to the power of 3 over 3. Now 3 to the power of 3 is just 3 times 3 times 3, which is 27 over 3, which is 9, which is 3 to the power of 2. And I pointed this out because I wanted to show that when dividing two terms, two exponentials with the same base, you can subtract the exponential of the denominator from the exponential of the numerator. So as you can see, we have 3, because this here is 1. We have 3 to the power of 3 minus 1, which is, oh god, that should be a 1. Sorry about that. 3 to the power of 3 minus 1, which is 3 to the power of 2. Which we got over here. So I just wanted to show that that's just an algebra 2 way, or even an algebra 1 way of simplifying exponential quotients. So that means that x to the power of x over x is actually equal to x to the power of x minus 1. And that is because the exponent of the denominator is 1. And so we're just subtracting the 2. So we'll fill that in here. We'll say x to the power of x over x is equal to x to the power of x minus 1. And now we just have to simplify our final term, in which I'll do so down here in green, or orange, sorry. So we have natural log x times x to the power of x plus natural log x minus x squared. Wait, that should be a multiply. Yeah, it is. I don't know why this is. Let me fix that quickly. Okay. Times x squared. And so what we're going to do at this point is we're going. Okay, I apologize for that break. I realized that I made a mistake over here, just with writing. The math is all correct. I just wrote down something incorrect. So, as I said, this should be a multiplied, or a multiplication sign. And this right here should be x to the power of x, not x squared. I don't know why I put x squared. Over here, I put x squared as well. Over here, you can see that it's x to the power of x. So I don't know why I did that. Let me fix that. You may have caught that if you were working on this as well alongside me, but yeah, that is going to be x to the power of x. So we can now actually simplify this a bit further. What we can do is we can draw out the x to the power of x from both this term over here and this term over here, such that we end up with x to the power of x times natural log x 1 plus natural log x. And in fact, that's as far as we're going to simplify this term over here. So we can plug that into our final equation, and I'll write it down here. Might as well do that in a light green. So we can say that y prime is equal to x to the power of x to the power of x. And let me cross this out because this is just an unfinished thought. Times x to the power of x minus 1 is because x to the power of x to the power of x is equal to 1. X to the power of x over x is equal to x to the power of x minus 1 plus this term over here, which we can say is x to the power of x natural log x times 1 plus natural log x. And in fact, that is our final answer. That is the derivative of x to the power of x to the power of x. Now, I have not actually looked at any other processes of finding x to the power of x to the power of x. I did come up with one, a separate process. It's very easy because it's just there are so many ways to differentiate this this function x to the power of x to the power of x. But my point being is that I don't know if this is the most efficient method. This is the correct answer because after I was done, I looked at the correct answer and ours matched. And so, or at least it matched the general consensus of what x to the power of x to the power of x is, which is, of course, this, because, I mean, it's math. The consensus is practically a fact. But as I said, this may not be the most efficient method of finding x to the power of x to the power of x. But then again, it doesn't really matter because the derivative of x to the power of x to the power of x doesn't really matter because it's not applicable anywhere. But that's it for today's video. I hope you learned something. If you have any suggestions for future videos, please put them in the comments below. Thank you.